In the last video, we counted all paths from 0, 0 to 6, 2 that never return to 0. The answer was the number of all paths from here to here minus the number of all paths from here to here. This gave the answer n51 minus n53. Now remember that this was a simplified version of the original puzzle. The original puzzle was to count all paths from 0, 0 of length 6 that never returned to 0. The end point was not specified there. We added that extra condition in the last video to simplify the problem. Now we shall attack the original puzzle. How many paths of length 6 starting from the origin are there not returning to 0? I pause to give you a chance to think. Basically, we shall apply the simplified version to all the possible endpoints and then add. So the question is, what are all the possible endpoints? The maximum possible height will be 6, which is attained if we always move up. The minimum is similarly minus 6. So the final point of a path of length 6 must lie among these points. Are all this possible? Well, no. Because the duration of our path is 6, which is even, and we cannot reach an odd position in an even number of steps. So all the possible endpoints are these. Out of these, we are not allowing this because we are considering paths without any 0 return. Now let's count the number of paths without 0 return to each of these separately. For this path, for this point, the number of paths from here to this, and that will minus the number of paths from here to this. Now once you see the pattern, this and this, to see the pattern, you should be able to understand that the number for this final point will be this. Now the negative half contribute the same values placed symmetrically. Now if you sum these, the sum will telescope out nicely. The 5 5 will cancel out, the 5 3s will cancel out. So finally you are left with just this n51 and n57. And the same number is contributed by the negative half, so the final answer will be 2 times n51 minus n57. But this n57 is actually equal to 0 since 7 is more than 5. You can never reach 7 in only 5 steps starting from the origin. So the answer is simply 2 times n51. Now I shall give you your exercise. Generalize this when I replace this 6, that is the length of the path, with any even length. That is, if a simple symmetric random walk starting from the origin runs for 2n seconds, then what is the chance that it will never return to 0? And as a bonus surprise, try to answer this question. Is this probability greater than the chance that it ends at 0?